All right, guys, so welcome back. So as I was saying about ratios, you would realize that ratio has to do with shares. Now, oftentimes we may refer to the shares. Let's say we have a share of 2 to 5. That's the ratio of which two persons share are being. So one portion is a smaller portion, the other one is a larger portion. Now, sometimes we may want to find out what fraction of the total is each portion. So what is the total thing that we share? How much things we had in all?
Had 12 mangoes in all, sir.
All right. So we had 12 mangoes in all. Is this a ratio that it was in, 2 to 5? No, it wasn't 2 to 5. It was
5 to 1.
5 to 1. Let us use the 5 to 1. All right, so as I was saying, if we put it back in the form of 5 to 1, then we would have what original share was 10 to what? 10 to 2.
Mm-hmm.
And suppose I say, what fraction of this of the total did you get, Miss Waysom? What fraction of the total?
10 out of 12.
Right, so you would take, Miss Waysom is 2 you would get? You got what? 10.
10 out of 12, sir.
Right, so you get 10 out of 12. And the other person would get what?
2 out of 12.
Right. Now, so ratios, sometimes you write them as fractions. And so the whole idea of ratio becomes the word rational, which has to do with what? Fractions. So when you hear the word rational numbers, you are now thinking about numbers that can be expressed as a fraction. And as we know, a fraction has a what? A numerator and a denominator. Now, so my question to you though, are whole numbers fractions? Anybody? Miss Green, are whole numbers fractions? Let me ask the question in a different way. Are whole numbers rational?
Yes. I think so, sir.
You think so? You're not sure, you think so. What about you, Miss Scott?
No, sir.
You don't think whole numbers are rational? Explain why. Why I say they're not rational?
Because it does not include a fractions.
All right, can you express them as fractions too? Can we express whole numbers as fractions, Miss Tavia?
Yes, sir.
All right, for example, suppose you have the number 2. How could we express this as a fraction?
It could be like 0 out of 2.
0 out of 2, how would you write that? Remember, a fraction must have a numerator and a denominator. Which one you would put in the numerator, which in the denominator?
The 0 at the bottom and the 2 at the top.
Okay, now we're getting into some serious situation now. Would that be, if you express 2 as a fraction, would this be the answer?
No, I would say the 0 at the top and the 2 at the bottom.
All right. All right, so let us, so one person say 0 at the top, 2 below. Anybody else agree with these? What about you, Miss, let me ask, Miss Cummins? Do you agree with any of these? We're expressing 2 as a fraction.
So I'll say 0 at the top and 2 at the bottom.
All right. If you have 0 at the top and 2 at the bottom, what this gives you? Are you aware that the bar in a fraction can be treated as a division bar? The bar here, this bar. Are you aware that this bar can be treated as a division symbol? Suppose I have 4 over 2. What would that be saying to you?
Would it be 2 over 1, sir?
If you're canceling, you could say you use a number to divide the 2 and you use a number to divide the 4. In this case, you could use 2 to divide itself and 2 to divide the 4. So 2 into 2 goes 1 and 2 into 4 goes 2, right? That's one way and you will get what? 2 over 1. But if you're treating it as a division, 4 divided by 2, what would you get? Two into 4. Ms. Green, you're saying something, but you kind of, what you had said kind of disappeared. You want to say it again?
2, sir.
All right, so if you're treating the this bar as a division symbol or a division sign, you would say 4 divided by 2 give you 2. Everybody agree with that? And if you cancel it down, you will get 2 over 1. But here you can also treat this 2. You could treat this 2 as you're dividing it by 1. So you say 2 divided by 1 will give you what? It will give you what?
2, sir.
2. Okay. What about this that we have here? 0 divided by 2 will give you 1.
Two, sir.
2, sir.
0 divided by 2 give you 2.
0.
What about this one? 2 divided by 0.
2, sir.
2.
Yeah. And then 2, oh, 2 into 0. I think you'd get some decimal for the bottom one, sir.
Oh. Ask you a question, guys. I don't think you're thinking about the answer that you're giving me for these two, because these are nowhere correct. But let me ask you a question, though. what amount zero values? How much you get for zero?
Sir.
Huh?
Nothing.
Zero is nothing, right? If you have $0, you have no dollar. You have nothing. So zero is nothing. My question is then, if you have zero, which is nothing, and you divide nothing by 2, what you get?
You won't get back the 2.
You can't get back 2.
So you get 0, sir?
You get nothing. Because if you have nothing already and you divide it up into 2, if you have an empty box and divide the empty box into 2, the box still empty.
Oh.
You get the idea?
Yes, sir.
No, sir.
All right. Suppose you have $0, all right? And I take that $0 and divide it into 2 parts. How much money you have?
So you can't divide the $0 into 2 parts.
Why?
So because $0 would be nothing.
Right.
Right, so if I half the nothing, what would I get?
Nothing.
Nothing, right? Because if I split nothing into 2 parts, then this is 1 part of nothing with another part of nothing. It's 2 nothing you have. So it is 2 nothing, which is the same as nothing. You follow what I'm saying? Guys? All right.
Yes, sir.
So remember now, over here when we say 4 divided by 2, we divided the 4, we want to say how much parts or how much 2's we can get out of 4, or how many parts we can divide the 4 into. So we can divide 4 into 2 parts. 2 into 4 goes 2 times. Now 2 into nothing goes 0. Is that clear, guys? So
Repeat, sir.
this is actually 0. 0 divided by 2 give you 0. Let me ask you another question, because it seems like you're not so convinced. Suppose I have 6 times 0, right? How much would I have? If I have,
0 for the answer, sir.
if I have,
6,
if I-
sir.
if I have 6 0, how much would I have?
6 times 0 is 0, sir.
0, sir.
Yes,
0,
0, right? Because you have 6 nothing, is still nothing. Now, 0 divided by 2 would be the same as 0 times a half. Because you see, if you multiply 0 times the 1 up here, you get 0 in the numerator. You see that? Everybody see that? Following? 0 times a number give you back what?
0, sir.
0. 0 times a half give you back what?
0.
0. 0 divided by 2 give you what?
0.
0, because it is the same thing as 0 times a half. 0 divided by 2 is the same as 0 times a half. All right. I know some of these ideas are not very cemented in your mind as yet, but these are some simple ideas that people often have misconception about. So I'm trying to clear them up for you. All right. Now, what about this one up here? This one that we have where 2 divided by 0. What should we have for the answer? 2 divided by 0.
0, sir.
0, sir.
People pick that to people upliftment.
You get 0. I want you to think about it carefully, you know. If we have 12 mangoes, right? And you're dividing it into 3 parts so that you can share it evenly among friends, 3 friends. So 12 divided by 3 would give you what?
4.
So you have 12 mangoes and you divide it into? So you get 4, right?
Just then go over there.
Everybody agree with that? Hold up your hand if you're agreeing with what I just said. All right, good. Now my other question to you now. If you have 12 mangoes and you divide it into if you divide it into 0 amount, or not 0 amount. Let me say you're dividing it by 0. You have 12 mangoes and you're dividing it by 0. How much would you get?
0, sir.
12, sir.
I have a KCM 12 mango.
What's a 0?
You see, that's a mathematical, what we call a mathematical problem, because you cannot divide by 0. What I want you to do, if you have a calculator close by, or I don't know if you are able to use a phone. If you're not, if you are able to use a phone, just look at the calculator section and type 2 divided by 0 and tell me what you get from the calculator.
It is showing an 8 setting sideways.
It's that is the infinity sign. Infinity symbol. So 2 divided by 0 give you a sideways. Okay. All right. Really and truly, in mathematics, we don't usually have 0. We don't usually divide by 0. We say that it is undefined to divide by 0. Because when you think about it, if you have 12 mangoes and you're dividing the 12 mangoes by 0, that means you're saying you're dividing 12 things by nothing. How can you divide something by nothing? Can you divide something by nothing? How many parts nothing have?
None.
Sir.
Right, so it's a problem. We know that maybe there may be some logical thing about nature, but when you try to divide nothing, divide something by nothing, it doesn't work. So for most calculator, maybe different from your phone, I don't know where they get the infinity symbol is, but for most calculator, they will tell you that either you have a mathematical error or it is undefined, right? So for this one, the answer here would be undefined, because we don't have a definition for it in math. Is that clear, guys? So we cannot divide by 0. It's undefined. Oops. All right, so this one don't have a meaning. It is impossible to divide by 0, guys. All right. Now, if we are to write a whole number as a rational, what's the correct way to write 2 as a rational? Or 2 as a fraction?
Sir,
Huh?
1/2.
No,
2/1.
2/1. Why we don't 1/2?
Because the half.
1/2 is what? A half.
Half.
Is a half the same as 2? No, right? But we know that 2 can be written as 2/1 because this is the same as saying 2 divided by 1, we will get back the what? 2. So all whole number, you can write them as a fraction by putting them over 1. Can we write 0/1 as a rational?
I guess so, sir.
You're guessing? Why are you guessing? When you're guessing, it means
Well,
you're
I'm
not
just
sure.
kind of comparing. No, sir, I'm just kind of comparing it like back in school, like, you know, when you do something and if you even get all of them wrong, you get 0 out of 10. So I'm guessing you get 0 out of 1. So that would have been a fraction just the same, or a rational as you would say.
Okay, all right, fair enough. I'll work with that. But all whole numbers can become rational by putting them over 1. We know that 0 is a whole number. So just like the other whole number, we can write it over 1 to express it in the form of a fraction. Because when you put them over 1, what you're making is a fraction. A numerator here with 0, the denominator is 1. Over here, the numerator is 2, the denominator is 1. So all whole numbers can be written in the form of a fraction by putting them over 1. So does that answer the question? Are whole numbers rational? Miss Green, are whole numbers rational?
Yes, sir.
Miss Cummins, are whole numbers rational?
Yes, sir.
Miss Scott, are whole numbers rational?
Yes, sir.
Mr. Pagano, are whole numbers rational?
Yes.
Is everybody clear on that now? All whole numbers are rational numbers. Now, if we have all whole numbers as rational, would all integers be rational? Do you think we could express, what are integers again, anybody?
Negative or positive numbers, sir. Or you'd say whole numbers and negative numbers.
All right, so negative and positive numbers, which is the same, because remember now, we only are somewhat making a connection without they relate to each other. All right, because we see that some whole numbers are integers. We see that some integers are whole numbers. And we also going to consider now rational. We see that whole numbers are rational. So my question to you is, can we have negative rationals?
Yes, sir.
All right, so are negative numbers rational?
Yes, sir, I believe so.
Right, just in a similar way to how we treat whole number, we can write 2/1 to make it whole. We could also have -2/1, and that would also make it into a rational. So 2 over 1 make it into a rational. Negative 2 over 1 also make this into a rational. So this whole number, as a rational, we put it over 1. This negative integer, if we are to make it rational, we put it over 1. So all integers are rational numbers. Is that clear to everyone? All integers are rational numbers. What are rational numbers again, guys?
Numbers that can be made fractions, or whole numbers that can be made expressed as a fraction.
Right, numbers that can be expressed as a fraction with a numerator and a denominator, those are called rational. Irrational numbers now. Anybody have any idea what irrational numbers are?
Opposite of rational, sir.
Okay, so I was actually looking at the examples here. So rational, we say that numbers which can be expressed as fractions whose numerator is an integer and whose denominator is a non-zero integer. Now this is important when we say the denominator has to be a non-zero integer. Can anybody tell me why you think we cannot make the denominator as a zero integer?
Because we cannot divide with 0, sir.
Because we cannot divide by 0, right? So the definition, if you have a 0 in the denominator, it would not be a rational. So that's why we say that the denominator has to be what? A non-zero integer. Is that clear to everyone? Raise your hand. All right, good. So here we give you an example of how we can describe integers with this definition. So this is also another definition for integers. Sorry, not integers, for rationals. So rationals equal numbers which can be expressed as a over b, where a and b are integers and b is not equal to 0. All right, so the denominator cannot be 0. Note, 0 is a rational number because it can be the numerator, but it cannot be the denominator. All right, these are examples of rational. 0 divided by 3, 0 divided by 8, these are rationals, where 0 is in the numerator. All right, we're going to talk about types of rational. We have different types of rational. All integers. Why? Because all integers can be expressed as a fraction, where we put them over 1, they become a fraction. Fraction whose denominator do not equal to 0. So all of these are different types of rationals. We have decimals, which have a limited number of decimal places. So these are also rational. Anybody know why we say decimals are rational? This number, 3.28, why we say it is a rational?
So because decimals can also go into a fraction.
Right, because decimals really are, they are special types of fractions. What make decimal fractions special? Anybody? Anybody know what the prefix deci means? When I hear deci, what comes to your mind? All right, let me give you an idea. If we have a three-sided figure, what we call it? What are three-sided?
Triangle, sir.
If you have a four-sided figure, what we call it? What we call four-sided figure, guys?
Class, my lady.
What do we call a four-sided?
Square or rectangle, sir?
Or what do we call a five-sided figure?
Sir, I wanna
Pentagon.
Pentagon. What do we call a six-sided figure? Anybody?
Hexagon.
Hexagon. All right. What do we call a seven-sided figure?
Hexagon, sir.
Heptagon. H-E-P. Heptagon. All right. What do we call a eight-sided figure?
octagon, sir.
Octagon.
Right. And a nine-sided figure we call what? Say that again.
Nonagon, sir.
A nonagon, right. Now, what do we call a 10-sided figure?
Decagon.
Decagon. Now, if we have 10 years, what we call it? Decade, right. If we have a decimal system, what it means?
Repeat, sir.
If we say decimal, what that means?
Is it combining, sir?
No, the prefix deci. Decimeter means what?
Part of, sir.
You guys are not getting the idea. Anything that says deci
10, sir.
means 10, right? That's what it means. Anything that says deci means 10. So when we say decimal or special fraction, they are fractions where the denominators have powers of 10 in them. That's why they call decimal. Look at this one here. What power of 10 is 100? 10 to how much power?
Second power, sir.
Right. So if you have, say, say 28 over 1,000, the denominator would be to how much power? 10 to how much power?
Third.
28 over 1,000. How many zeros in 1,000?
3.
So what's the power?
3.
10 to the 3. How many zeros in 100?
2.
What's the power?
2.
The second power. How many zeros in 10?
1.
What is the power?
First.
Right. So the number of zeros in the denominator with a 1 can tell you the amount of powers that the number 10 is raised to. So if you have 1 with 1 0, it means that 10 is raised to the power 1. If you have 1 with 2 0, which is 100, you have 10 raised to the power 2. If you have 1 with 3 zeros, 10 raised to the power 3. You get the idea? Now, any number that are expressed with denominators of powers of 10, they are called decimals. And so they are special fraction. Now, to write decimals, we generally use a point to separate the whole number part from the fraction part. So the number that comes before the point is the whole number part, and the numbers that come after the points are the fractional part, right? So if you are to write this decimal 3.28 as a fraction, what you would generally do is you see how many digits come after the zero. Sorry, after the point. How many digits come after the point?
2, sir.
Right, so it means that in our denominator, we are going to write 1 with 2 zeros. And then now we put the entire number without the point above in the numerator. That's how we form it into a fraction. All right, so decimals can be written as fractions by doing that conversion, right? So they are actually fractions. So decimals are actually fractions that are special fractions with denominators of powers of 10. Is that clear to you guys? But we just simply write them in a short form where we use a point to separate the fractional part and the whole number part. Now you don't have to worry about all that I'm explaining now. When we get to decimal, it will come a little clearer to you what is happening. All right, guys? Now we have what we call recurring decimals. And why we call these recurring decimal? Because the last digits are the digits will reoccur on and on. So in this one where you have 0.3, this 3 here continues on and on without ending. When something continues without ending, what do we call that?
Infinite.
It is infinite, right? And so we say that it goes on to infinity because it goes on without ending. All right? So for recurring decimal, the digits reoccur on and on to infinity without ending. So in this one, if you notice, they put dot after it. So the 3 going to keep reoccurring on and on to infinity. Now for this one down here, which is also a recurring decimal, these 3 numbers that come after the point will continue reoccurring. So you're going to have 2, 7, 2, 7, 2 again, and so on until infinity. All right, so we call these recurring decimal because the last digit